Hey viewers! Today we have a short video in which we prove the Pythagorean theorem. The Pythagorean theorem states that in a right-angled triangle, the sum of the squares of the two shortest sides equals the square of the hypotenuse. There are two easy ways and one complexer way to prove it. First, we will do the easy ones. Starting with a triangle with short sides A and B, we can make it into a square by adding a block of C times C and 3 additional triangles. These triangles are the same as the initial one. What? You want me to prove it? Sure. The 3 angles in a triangle add up to 180 degrees, as you should all know. The angles in the bottom part of this figure, as you can see here, also add up to 180 degrees, as should be obvious. Since angle alpha is the same in the triangle and in this new figure, and the second angle in this figure is 90 degrees by definition, since it's a square, the remaining angle in the figure must be beta, the same angle as in the triangle. Now, in the new triangle, we have angle beta and a right angle, meaning that the remaining angle must be alpha. We have now proven that the triangles have the same shape, so finally we take a look at the hypotenuse and see that both of them are size C, which proves the triangles are equal. Back to our initial situation then. The created square has sides a plus b, making it have an area of a plus b squared is a squared plus 2ab plus b squared. The area can also be calculated from adding up its components. That's 4 times a half AB for the triangles plus c squared for the big square in the middle is 2ab plus c squared. Since both areas must be the same, it follows that a squared plus b squared is c squared. Okay, our second proof then. If we take the same square and rearrange the triangles, we can clearly see, straight from here, that a squared plus b squared is c squared. It's probably the easiest proof of this theorem. Finally, the proof Pythagoras himself found, although historians aren't sure he had anything to do with the theorem at all, but we will not go into that today. If we add the a squared, b squared and c squared squares to the triangle, and add some more shapes to make a big rectangle, we can once again calculate the area in 2 ways. First, the sides of the rectangle are a plus 2b and 2a plus b, resulting in an area of 2a squared plus 5ab plus 2b squared. The sum of the different parts that make up the square results in an area of a squared plus 5ab plus b squared plus c squared. Since, once again, these areas must be the same, the result is that a squared plus b squared is c squared. I hope you learned something today, and I will see you next time.